Hello, my name is Michael. You're welcome to my YouTube channel. And it feels good to be back after a 4-year break from YouTube content creation. I had to focus on a few things on my side, but now I'm glad I'm done with those now and I can spend more time creating rich content for you, and I hope that you'll find them useful and helpful in your projects as well as in your different use cases. I would like to also thank you, especially those of you that came across my videos in the past years. I thank you because most of you did like the video. I could see some instances where they were shared, and as well as the subscriptions. Thank you so much. I really appreciate it. I intend to stay longer this time around to create more useful and helpful content. For those of you who probably are seeing my videos for the first time, this is just a little background about me, and I hope that my content would make a positive impact in your endeavors and your use cases. I'm also open to receiving questions on the comment section, responding to you as well. And I really appreciate if you could like and share, also subscribe to encourage me to dedicate more time creating this content. In case you are wondering where my previous videos are, I will drop the link in the description, and when you have time you can take a look at them and tell me what you feel about them. Today's agenda is on a topic called ISATAP, and here we'll talk about the ISATAP protocol itself. I will share with you the scenario that I've prepared to be able to explain this, and the implementation part as well as the verification. Then we will talk about the analysis using Wireshark, where we would sniff the packet and see what the headers and the field in the headers of an ISATAP packet looks like, after which we will wrap it up with a conclusion. So the ISATAP, as I said before, is an IPv6 addressing protocol, which stands for Intra-Site Automatic Tunnel Addressing Protocol. This also means that the use case for this particular technology is mainly for intra-site connectivity. That means you can't really use this across the internet for the purpose for which it was designed. One thing that is really interesting about these technologies, it's very simple to deploy. The only thing is that you need to be sure how you want to deploy this based on the design and, let's say, the architecture of the infrastructure where you intend to deploy it. But it's really simple, and I will show you that in a moment. The other part is that it references IPv4 as a link layer protocol for IPv6 traffic. That simply means IPv4 is an underlying technology for the IPv6 traffic that will travel over it, which is why it is referred to as the tunneling protocol, because the IPv6 packets are embedded, or they are encapsulated in IPv4 header, which means that it's able to transport IPv6 traffic through the underlying IPv4 infrastructure. And most of the time you get to use this during IPv6 migration projects, especially where you have IPv6 islands in different scenarios and you still have a significant part of your infrastructure as IPv4. And that's exactly why this is really a cool and very simple technology to use, especially in situations where you have application servers that are already sitting in an IPv6 only environment, and you will still be able to communicate with them over your IPv4 infrastructure. Importantly is this part where you would already find an identifier for ISATAP traffic or ISATAP packets. This value here is usually found in an IP address of an ISATAP packet, and you will definitely see it when we do the packets analysis. And for more information, you can check the RFC links here. I will also ensure that this is also in the description of the video, so you can check this out and read more about it. Here is a scenario, the network architecture which I've provided. I created this from my lab environment, which is heavily deployed on an SD-WAN fabric. And all of this that you see, except for this device here, are virtual. They are all in the lab environment, and this is just the PC from which I'm speaking to you right now. I'm connecting to this firewall through my lab extended wireless network. So I have this wireless connectivity to the firewall here, which is from FortiGate precisely, and that is sitting behind the V-Edge, which is more like my home lab network, or let's say the physical part of my home is sitting behind a V-Edge, which is terminating my connections to that V-Edge, and that V-Edge is already integrated with the fabric where we have the controllers as well as 2 virtual remote sites. Now, the topic for today is going to focus more on these 2 aspects because, as you can see, this architecture is made up of 3 key modules. I have my physical home lab here. I have the virtual lab environment, which is the core part, and that's why it's referred to as the IPv4 only infrastructure powered by the SD-WAN connectivity or infrastructure fabric. Then I also have an isolated IPv6 only environment, which is sitting just outside of the site, literally, as you see. We will not talk much into how converged this architecture is, but one thing is certain, I will be able to show you how the traffic traverses from my PC through the physical wireless network and into the lab environment through the SD-WAN fabric until it gets to the ISATAP gateway itself. Here, I'm just describing to you the module of this architecture, and that's exactly what I said before, where you're seeing 3 sections or 3 key parts of the architecture. The dual stack host endpoint, which is this one, as well as the core, which is the SD-WAN fabric that's in here. And then the last part is the IPv6 only infrastructure where the target server resides here as well. This is just a summary of what we have in the IPv6 only environment, but in a couple of time I will share with you what we have actually in there. And now let's assume that you are the network engineer, let's say the project, or the technical project engineer, or even the architect of this private company, and the task is that they just migrated or created a new environment for IPv6 connectivity. For that reason, they want to start small and start slow, where they are creating an isolated environment which is strictly IPv6 for explorative purposes. And that's the reason why you would have some of these use cases. And the task here is to establish a connectivity over the existing converged IPv4 only infrastructure without having to touch it at all. No modifications are required on this side. They only just require certain PCs or group of PCs or users to be able to connect from their laptops or whatever endpoints they're using to specific servers that are in the IPv6 only environment. And there are so many ways that you can do this, but the easiest and the most direct way to do this would be one of which is the ISATAP. There could be other cases where you do translations, and that would still be the case. But this is more like the simplest of them that I have seen so far, and I think it's important to share this with you just in case you come across such cases in the future. Here is the implementation architecture where I have the IP addresses now, but importantly is the IP address of the endpoint, which has both IPv4 and IPv6. Of course, you're familiar with this, which is the link local address. Okay, so we have the design that will be implemented here. And as you can see, I have the IP addresses of the interesting points that we would need to do something with. But the basic requirement here is that this PC should be able to reach the ISATAP gateway on its IPv4 address. And that's exactly what I will start with. And after then, we will quickly do a trace route to see how the traffic traverses. I expect that the traffic would go in this direction and to get to that destination. So let's check this out and see. First, I will run a ping test and see how things will go. And before then, let's just quickly check our IP address. You can see this is the IP of my wireless network, and that is fine. The next would be to check the connectivity, which is here, to the ISATAP server. And I can see also that it's responding well, and I just need to run a trace route to the same server from this, just to be sure that it's going through this gateway. And that's really something that we need to confirm, and that's cool because I can see now it's going through this firewall, which is the 250, that's 128.250, and that hands it off to the VH, which is the 130 that we have here. That then sends it through the fabric, which then lands to the other VH here, the VH2. I hope that, yeah, the VH2. Then that also sends it to the internal router before it finds its way to the gateway eventually, which is the last part. Now that we have checked the trace routes, let's now check the status of the ISATAP adapter, if there is anything like ISATAP adapter on this PC yet. And now we see wireless Ethernet, which is wired, and of course there is nothing like ISATAP there. The way to check again would be through this ISATAP related command, and you will find most of these, not all of them, in the relevant documentation from Microsoft. So we check the interface, IPv6, ISATAP, and now we do show status, which is state. We can see it's disabled, which is fine, and we check again the router, which is also disabled. And this simply means that we don't have ISATAP enabled, and the ISATAP does not have any configuration with respect to the gateway it should reference. What then happens is we have to check the other side because we need to be sure if there is anything that is on the other side, which is the router. And here I have a 7200 series router for this gateway. Just for information, this router, which is internal, as well as the server, which I'm actually using a router serving the purpose of SSH server as well as HTTPS server or something. I need to turn that on though, but the SSH is fine, so we can use that for a quick test for the connectivity once we establish it. But back to the gateway, in this case, we have to check what it has configured already. So I have this IP address, which is fine. I have to check the interface as well, which is fine. Let's quickly check description and see if there is anything. There is no tunnel, but we have a looper, and we also have the internal network interface, which is on this level. So like I said, some of those parts were already configured, but on this there is no configuration, so we only have to configure this IP.1 as well as the other things that are necessary for this gateway to be ready to receive connections and also terminate them. One of the things that we need to do first is to enable IPv6 routing to be sure that that router is IPv6 enabled. The next is that we have to create a tunnel. I will create tunnel 0, and now we should enable IPv6 on it. That already sets up the interface to acquire link local IP. We can check the interface of this and see if there is anything configured. At the moment, this is fine. We have a tunnel which is already created, and now we just have to enable the IP addresses that are required. And here we do IPv6 enabled, and we also configure the EUI format IP address for this, which is 2025 December 26th. Oh, sorry, that should be the tunnel 29th December, and we give it a /64 because it has to be in this EUI format. And now we specify the tunnel, which could be the interface or the IP. I would use the interface. in this case. And now we also set the mode of the tunnel to be IPv6 IP ISATAP. And once this is done, the tunnel is ready. Let's just do a quick verification there. And now we have the tunnel source as well as the mode. This doesn't require a destination because the assumption is that it is a non-broadcast multi-access interface, which means it would have a lot of clients, or call it remote sources, that are connecting. And that's the reason we cannot specify the destination, because it could be any source at all. But as long as they negotiate properly, they will establish the connection there. Now this is fine. I'll save this quickly. The next part is to create or to configure the IP on the internal network, which is this. Let's quickly check again. So we check the interface. There is no IPv6 address for now. And remember, this portion has to be IPv6 only. So we don't have to configure IPv4 addresses there. We only have to enable this first, and then we configure this as well, which is IP address to 2025.12.26, and now we have it to be /126, which is I think about 4 addresses there, but we're using 2, so that's all good. All right, and now we save this. Let's just test quickly that we can reach other side. I'll try. Okay, so that's good. So which means we can reach this side. But what about the other side as well? That is the remote segment here to the server. First and foremost, okay, maybe we should just do this quickly. 2025, 12, 26, 220, and that's 2. Maybe we start with that 1, which is good. And that's 2 is also good, which means we have a pre-existing route there, but I will show you how to do that in case you are not familiar with IPv6. It is very common. I'm using static routes, so which is not a bad idea for this simple architecture. So, and this is something that would also run through dynamic protocols as well. IPv6 for EIGRP, BGP for IPv6 as well, RIP, NG, OSPF v3 as well, or ISIS as well, as you may want to go for any of those protocols. You should be able to work with them basically. In this case, I will save this, which means our IPv6 island has converged, but we need this task to be achieved, which means my endpoint, I should be able to reach the server or any addresses here in this IPv6 from my PC, which is running both IPv4 and IPv6. And what we're about to do now is to establish a tunnel between this PC and this gateway for this PC to be able to overlay its v6 traffic to the v6 only bound environments. We will establish a tunnel between this endpoint and this gateway in order to overlay the traffic bound for the IPv6 only site. And to do that, we come back here. We have to create the gateway configuration first, or either way, you can also enable it first. So, but I just prefer to do this, and you can also quickly verify that one, which now has it and it's already enabled. The other part will be to enable the state, which now should have created the tunnel. And you can see from here we have the ISATAP tunnel enabled. And one thing which is really cool is that it creates the IP automatically, such that you would see the portions of the IP address, which is the first 64, and then the first 32 bit in the second part of it is the identification of the ISATAP packet itself, or the ISATAP IP address. So anywhere you see this, and remember the rules of IPv6 when you have continuous zeros. That's actually playing out here. And now the first part of the interface identifier, which is the first 32-bit value, is identifying the IP address to be that of ISATAP. The last 32-bit is the IPv4 address of this host, which is actually what you have. And if you check that out, it's here, which is coming from my Wi-Fi adapter. And that's exactly how this IP address is formulated or generated. Now that we have established this, you would see also that it's seeing this as a link local address of the gateway, taking the exact format as well. The first 64-bit is for the IP address. The first 32-bit of the interface identifier is the ISATAP address, and the last 32-bit is that of the IPv4 of the gateway, which you have here. Now, once you have gotten to this point, it simply means that you should be able to reach everything in that IPv6 only site. And that's exactly what we will do now. Let's now pick one of the addresses, which is the first one. Let's pick the first part of it, which is 2025, column 12, column 26, column 1. And that's really good once we get to this point, because what that means is that from this PC, I've been able to traverse the entire infrastructure up to this point into the IPv6 only environment. And now we advance to the .2 or the column 2, which is this internal address here. And the next to that will be the segment where the server is seated, 220 column 1, which is this interface here. The last part is then that of the server itself, which means I am able to reach the server directly from here. And that's exactly what we want to do. So this is what I wanted to show you. The next phase or the next segment will be looking at the verification. So let's start from here. As I've shown you before, you can quickly check the state of this session, which has been established, and that is exactly at this point. Visual state. You will see that. You will also see that of the router. That is fine. The next to check will be the adapter, which is also an evidence that everything went well with this. So on this level, you can be sure that there is a connection between the PC as well as its gateway. You also find the IP of the gateway in the default gateway address, IPv6 address in that case. Okay, now let's go to the router, that's the gateway side. And what that means is we could check this out and see interface tunnel 0. So here you also find out that we have the global unicast address, which is the ISATAP address. You can also see that's the IP address that we created as well, which is the EUI format. The link local address also, you can also find this, and you will see this is writing it actually in hexadecimal, and when you translate that, it translates to the IPv4 address. So because A in hexadecimal is 10, when you check that out, that's actually what it's giving us when you translate that forward. The other thing you want to see is something that has to do with the Wireshark for the analysis that we have to check. So in a nutshell, the summary of what just happened is that when you are initiating the session from the PC, you are sending a message of IPv6 called the router solicitation packet. And what that is more like you're sending an ARP request on the IPv4 LAN segment or Ethernet segment, and then that responds back, or even in the case of other multi-access domains, say things like a frame relay environment where you're sending the inverse ARP and then you're getting reply as well. But IPv6 is using this particular packet or message type in order to solicit for response. The response that it gets from the gateway is the router advertisement, which is an acknowledgement that says, I got your solicitation request, here is my advertisement. And once that advertisement is received by the side that is sending the solicitation request or message, that means there is a two-way communication, and that means the session can be established or has been established. After this, the host can now communicate with the server over the ISATAP tunnel. That's provided there are no restrictions, prohibitions, there are no blockers or firewalls in the path that is blocking any of those packets. And that's exactly another point where you could decide to troubleshoot if there is something going on between the two sides. Now, I'm just showing here what the tunnel looks like. It's going directly from this system to the gateway before the server. So that's all what it's saying. Very importantly, let's quickly run a trace route to those IPv6 addresses so we see how things are going. This is now to this server. Just run a trace route and let's see. And you can see it's only 3 hops as against the full path that I saw going towards the ISATAP gateway, which certainly means this is the overlay and that's the underlay. And you can see that the difference is really clear, which tells us it's going from this PC directly to the gateway and then to the other 2 nodes or 2 hops that we have in the path. The next thing is to analyze the packets. For me to gather that information, I have to turn on my Wireshark and I will monitor my wireless interface or my wireless adapter here. I would filter this to the address itself, or let's just say or IPv6. Now, to get much of the info, let's disable the status for now so that we can get more packets coming in. So I just do status and disable. Okay. And you can see the communication is really fast, and this is also showing that it's part of an existing communication, so don't need to worry. We'll get a full communication now once I re-enable it. So just for the purpose of this test, I will keep the router information as is. That's for the router, which tells me if I go back now to enable this, should be, let's just refresh this one. You have a clean face. Now we do enable. We want to see what happens. So I will have to remove that off the router as well so that we can monitor what's on our disable. Now when I check this, now let's check this. So it's disabled, and that of the state as well is disabled. So let's go now to the router. We have to set the router to this IP, and then we enable it, and we also enable that of the state. See what happens. It's exactly what I want to get. So here, let me maximize this a little bit. You can see, yeah, that's exactly what I'm looking for. It sends the solicitation. Let's just shrink this a little bit, because all of these are sent to a multicast address, which is what we have here. And once the multicast address has been sent a message, any other member of that multicast group will receive certain information and is able to respond with a unicast address. Here we have the first solicitation address or packet, which is going direct to this server. And you can see that the server received it and also responded with its advertisement. Now, one thing is very important, and that is the ISATAP addresses is what they are using to communicate over the ISATAP tunnel. And if you go further down here, you would see also that the layers of this packet, they are actually explicit, saying that IPv4 is the underlay, there is IPv6 running over that, which simply means without a converged IPv4 infrastructure, this IPv6 communication would not be successful. If we open this up a little bit, ignoring every other thing, what is important for this conversation or for this session is this part, which is explicit here, saying the source address of this ISATAP tunnel is this. That is the direction from the host towards the server. And the destination is the gateway itself, which is the host towards the ISATAP gateway. And that's exactly what we have. And when you click on this, you can see it's exactly the reverse. And this is really a cool one. And if we go further to do, let's say we run a telnet session and we pick on the IP address of the server, which is 2025.12.26.222, and we specify 22. It's established. And by the time we also check this out, we will see the traffic there, which is here. And you can see that, let's just shrink this into the follow string. You can see also here, which means we are able to access the server on port 22. And by the time we also try to enable HTTPS on it, we will be able to, let's try it for now and see what we get. So right now, there is nothing going on. We can actually just check this out from here, which is IPv6 address equal 2025.12.26.220::2. Up to this point, let's just combine it with TCP destination port 443 equals 443. Here we have this already telling us, oh, that port is not open. We only have one-way conversation there. So quickly we can do that here. Let's say it's alive. Just server. Really don't need to do anything more. In that case, if we go back here and then rerun this, and now it's alive, which simply means we got a feedback, and you can see also that it's possible to access your services over these. And one thing you should pay attention to in other scenarios is things like the TCP segment, because that could be something that you need to have to tweak, because when you're running on tunnels, you have to think about fragmentation of packets. You have to also think about the maximum segment size, especially for TCP related traffic or packets. So applications that are sensitive to this kind of behavior needs to be carefully planned in order to use this technology. But the most important part of this session is that you're able to establish the connectivity over your IPv4 infrastructure. That's really something I am really happy that I'm able to show you on this session. And now, in conclusion, you would see also that it's really simple. It's also very important to note that this is mainly designed for intra-site communication or connectivity. And if you have to use this, you have to essentially plan your project well as ensure that it aligns with the goal that you intend to achieve for the business. And of course, you will find it easy to deploy. And for other details and maybe some other information around this topic, you can therefore check the RFC links in the description of this video. You would also find a lot of materials out there on Cisco website, Juniper website, on other vendors, on Microsoft website as well, and so many other sources where people have dedicated time to explore this technology. I'd like to thank you for viewing, and I hope that you find it really helpful. Please drop your comment in case you have something that you'd like to share, or maybe you have an observation or you have a question. Feel free to share with me and I'll be glad to respond to you. And very importantly, please like and share. Also, you can subscribe and click the bell to get notification of my latest release. Thank you for viewing and enjoy the rest of the holiday. Bye.